Hey everyone, this is Evgeny and you're watching next episode in series about LangGraph introduction. Today we're going to check in some details the Trustcall library and what's happening under the hood when it changes the data. But before we dive in, I wanted to say thank you to one of our supporters with the name Alberto. So Alberto, thanks a lot for being with us, and I really hope that this video will be interesting for you. So Alberto, gracias. Alright, as I promised, we're going to look into some details about the way how Trustcall works under the hood, and for that we will be using a lot of data from the previous lesson about our instructions or directions, I call it those time. So this is our graph, our directive memory bot, and let's try and reproduce the same behavior we did last time. So I collected here already a dialog. And I'm just going to run this couple of rounds and see how it behaves. And again, let's remove all the directives we had previously. So we have an empty state kind of, and then I'm starting with the same question, talking about myself, about my profession, what I prefer, what I know, what my intention, all kind of instruction things. And so it works. We can see it was a human message. Chat has been generating something, then update memory node will be in place. And it's there, and we finished. And if I check memory now, I'm just repeating what we did last time. We do have a directive, or maybe instruction would be the more clear word here, but well, okay, we named directive. And we have a single directive which could help the LLM, the model, to guide it to a better response area. And have this include comments inside any code shared with the user. And now we are going with the second message, the intention to force next directives to be created. So we added a new message. We are starting the next round here. And the same, it says turn number 2, and the chat is preparing something and responding back with our request. And at this time, we don't care much about that, just interested in the memories, right, and updating memory thing. And so it happens we updated the memory, and if you go here, we have two directives already. The first one is breakdown explanation step by step, and we have avoid assuming user knowledge, provide detailed explanation of complex topics. And if you check, they were updated or created, or doesn't matter what, but a few seconds ago, meaning I don't see my previously created memory here. And that's probably because it was updated. That's why I wanted to show you this LangSmith thing, and let's give it a try. What I'm going to do, I'm just copy pasting it here, so I'm not closing our studio. But I'm going to LangSmith, and we're going to trace projects here, and I'm picking the one I'm using. And look at that, we do have two invocations already here. And well, in general, if you're in production, if you really have the application of calls, then you have to pay for this tool, unfortunately. But well, that's the reason they created it, right? To get money out of that. But anyway, for debugging purposes, it's for free. You can use it for free. You have some limitations, but probably you will never meet them if you're just experimenting with LangSmith, LangGraph, and all these kind of tools. And let's take a look at these two calls. So I'm picking the first one. And what do we have here? Well, let me make it bigger. So we see the hierarchy here. And look at that, we had the chat node and we had the update memory node. And if we click on the chat node, on the details of the OpenAI call, then what we can see here, we have a system message, and this is your helpful assistant, and this is our human message. This is the one I copy pasted. And then we have the output back. And again, we don't care much about that. So it's pretty clear, right? But anyway, it provides you some details, right, on what's happening. And you have some pricing, like how many tokens was spent, like latency. It was much faster for you, right? For me, it took like 20 seconds. And another note, update memory. And here we do have a Trustcall, and we have the extraction phase. So if I click here, look at that, what's happening. We do have, let me close this one to make it bigger. We do have a interaction directive tool call, and this is the name of our model, and the same name we provided as when we registered this model, the same name, the tool with the same name was created. So it was called, and this is very important. So the tool call happened under the hood with Trustcall. And what's there, we have the same input, update existing directives, and this comes from the system message. Probably I made a mistake. I marked it as a human message, not a system message, but this is coming from our update memory node. And this was my initial message that was being analyzed. And as a result, we had a tool call with specific ID. And the result of this call was directive include comments inside any code shared with user. So it's interesting, right? We never saw this before, and you can see like different details of your call and how it worked. All right. How can I go back here? Let's pick another one and close this one and then make this one bigger. And look at that. This is the second call where some updates were happening. And this time we have a chat. And if I click here, look at that. We do have the directive already inserted here. So this is a system message, and we saw it in the console already, right? And then the human message was the one I created, the second one, and here response here, and well, that's it. Nothing interesting. But what's interesting, you can double check, okay, your directive was inserted here as a part of the system message. That's the intention you initially wanted, right? But what's more interesting is update memory this time, because it doesn't say it was something else. Now it says extract updates, right? And generally we have two calls bundled into this update memory node. And if I go to chat OpenAI call itself, there are a lot of interesting information here. First of all, we can see two tool call happened. And for this one, it's clear, right? This is our model, and this was extraction, the information from the text and creating our memories or directives. And this one was from the Trustcall itself, and it was responsible for updating the already existing memories. So here we have this description of the tool, and what's interesting, take a look at that. So the system message was different. This time it was generate JSON patches to update the existing schema. And we provided the existing data already with the schema name and the ID and the directive and the message itself. So the system message again, it's wrongly marked as human, but it's system message. I'll double check it after the recording. And we have a human message to analyze. And as a result, what we have here, take a look at that. We had a patch doc, and it says that there is a planned update for this JSON document, and the editors replace the directive to reflect a step-by-step explanation preferences. And there are some patches definition of what needs to be done. So it's about replacing and the new values here. And this is kind of a reasoning why it should be done here. So this was update and how it looks like, the response from the tool. And this one is pretty standard. It's from the schema, it's just extracting the data and creating a new object. And this is pretty straightforward, right? It's just avoid assuming user knowledge, provide detailed explanation for complex sampling, just the way the model understood it. All right, so idea would be to replicate what we just saw in the LangSmith. And for that, we are redefining our models. Again, I will be redefining a lot primitives, objects, classes from the previous lesson. And here we do have our model. So it's instruction, it's interaction instruction. I renamed it from directive. I wasn't happy finally after filming the previous video. I thought, okay, maybe directive is the wrong word. And we have a list of instructions, and the explanation is the same from the previous lesson. It helps the model to understand better the intention of the schema and to extract the information in the proper way. So let me define it. Then what's next? We do have this Trustcall extractor, and this is the standard one, so nothing is really new here. We have a model, we are defining the tools, our schema, and we enable inserts. So it's possible for the Trustcall to work with single objects in the collection. And then having this first message, we are invoking Trustcall instructor, we are trying to extract this information using our schema definition. And if I check it here, I can see that, okay, maybe let me clear everything so we can double check that it's working. All right. So what we can see here, it was a tool call that was expected, right? We know that already. And the kind of result was this include inline comments in the code request. The information was extracted as an instruction. And so we can generate a list of single object of this interaction instruction, and the instruction is the one we get from the tool call. And this is the technique which we are going to use now for grabbing the information from the tool calling. And this is about listeners. So what I'm creating here, I'm creating a listener. And crucial point here, we have a list of tools, executed tools, which we are going to analyze in the future. And then we are registering this class as a function caller. And we grab all the executions or runs from the invocation, and then we go in through it hierarchically, and then we are checking if this was a chat model type, then we are just providing back some responses from the tool call, right? So which way it works here? Well, first we have to prepare existing facts the same way we did last time, and again take a look at that. This is the format that Trustcall expects us to provide, and we have here the unique ID of the memory. We do have the schema name, and we have the real data. And we have single memory so far that we received from the previous call. And now interesting things started to happen. So how would we inject our listener into the whole chain? We create an object of listener. And then we do have our Trustcall extractor, and we create another one with listeners, and we are providing our listener as a parameter here. And practically that's it. We do have back the normal extractor, which we can use as kind of a model, the same thing, right? So we do have a conversation, copy pasted from the previous lesson. We do have a system message, again, update existing directives. Okay, it's instructions, should be here. But now you see it was copy pasted really. And we're making an invocation of this listener and providing the list of messages plus system message and existing memories. And that's it. So what do we have here? We check the tool calls. We have 3 memories now. So the first one was updated, and we see this because of the JSON document ID. And the 2 other memories were created, right? And if you check the details, it was a 3 tool call. So we have this one, and that one. So one was about updating, and 2 new items were added. And this is the interesting thing, since we run this through the listener, then the listener should have collected all the 3 tool calls inside, right? And we can double check it by running listener tools. And look at that, we do have something. So we have a name patch doc, the JSON doc ID. We do have this planned edits thing, replace these instructions, a new set of instructions that reflect the user's preferences. We have the patches update defined here, where it starts here, right? So we're about replacing and adding something. And we have another tool call, and we have another tool call, and a lot of information is stored here. But if you think about it, that's not readable, right? Because what you do is this: you cannot just show it to your user and offer them to extract it on their own, right? It's really a nonsense thing. So what we can do, we can write a helper function that would extract all this information and show it in a more presentable way. And this is the function. I'm not going through it a lot, just maybe as a hint, the way I created it. I described all the details about the task to the cascade, and ask cascade to create the function for me. And that's the way it was created. So in general, it goes through all this information and generates a proper viewed presentation of that. So let me define a function, and then we're just reusing it. And take a look what we have here. We have document 1, and this is the unique ID was updated. And here's the plan to replace the existing instruction with a new set. We saw it already, right? And then 2 patches to replace something and to add something. And then 2 new memories were created using the tool interaction instruction, which is schema name and the content. All right, this was another short video about fine-tuning different ways and looking under the hood on how these memories are organized, how they are being updated, and showing you some ways how can you use that in your applications. And it was me, Evgeny. I really hope that you find this information interesting and useful. I really appreciate that you stick with me till the end of this video. And I will see you next time in the next video about LangGraph introduction. See you and bye-bye.